Okay, so we got 2-6 graphs of rational functions. Elk time this week, we're looking at completing the squares, writing vertex form of the equation f of x equal a times the quantity x minus h squared plus k. We're looking at completing the square to write it that way. That means we're completing the square with everything on the same side versus, setting it equal to something else, like the regular completing the square is. And when you're completing the square, your leading term must be 1. That leading coefficient, your a value, has got to be 1. We're looking at making polynomials from factors and given zeros, real and complex. So that's what's going on. If you want some practice with that, that's what I'm doing. Okay. Some of them will be familiar to the same ones that we've done in notes as well, or just regular homework time, place to study and ask questions if you need to. Okay. So when we're getting going today, we will do a little long division today. I know everybody's pumped about that, just me saying that as we're going through, but we're working with rational functions, and rational functions are just fractions, and we just haven't divided them yet. So I'll be able to find the domain of rational functions, describe the graph's behavior near x values not in the domain, meaning we're going to describe the behavior around the vertical asymptotes. Okay. Determine the transformations of the reciprocal function based on the equation, and find all the asymptotes using algebra, graphs, and limits. Now, that's basically what we're doing today. The analyzing graphs, filling in domain, range, continuity, increasing, decreasing, symmetry, boundedness, local extrema, asymptotes, and M behavior. Please pay attention to that when we start doing that, because it is something I'm going to expect you to be able to do, and yes, you'll be doing something like it on the test. So make sure that you're prepped for it and you know what's up. Now, when we're talking about real functions, specifically rationals, it's just a function that hasn't, it's a division function. That's all. Rational is just a division. So we have a f of x, and we're dividing by g of x, and that's giving us our rational function. So we have two polynomials that we're dividing to give us a rational function. Rational functions are ratios or quotients of polynomial functions. The domain of the rational function is set of all real numbers except the zeros of the denominator. Now, your rational function is continuous along its domain, okay, because we kick out the areas it's not. Every rational function is continuous on the domain as we go through, and get rid of this. I have no idea what that's there for. Okay, but when we're finding stuff today, wow, okay. I'm looking at things, and we'll talk about this limit in a second. Let's look at this and see what's going on. Okay, we're supposed to find the domain of a rational function. Find the domain of f and use limits to describe its behavior at values of x not in its domain. Now, that's different than the n behavior we've been working on. So we've talked about n behavior, what happens as it approaches infinity and negative infinity. These are kind of, what is it doing on either side of your vertical asymptote, okay? So first of all, when I look at this function here of f of x, okay, I know it's the, got a shift to the right 2 units, so shift right 2 units, shift 2 units right. Somebody actually write it in. So I know I got a vertical asymptote of x equal 2. Okay. I also have a horizontal asymptote here. Okay. In this case, as x approaches a really monstrous number, that is going to approach 1. Now we've talked about talking about the limit of horizontal, talking about our limit for the horizontal. So as we have x approach infinity of f of x, or limit of x as approaches in negative infinity of f of x, we're talking about what is it going to approach, okay? And in this case, it's horizontal asymptote. In both cases is 0, okay, when we're looking at that. So it's n behaviors, part of that horizontal asymptote. So we're looking at that approaching 0, y equals 0. So the domain that Can have 2. If I want to put it in, let's take care of these guys for a second. I'm going to group that together. And we're going to squeeze that down because I also could put it in 2, not including 2, union to infinity, if I wanted to do in that notation as well. So either one of those for my domain. But let's talk about what's going on with our graph around our vertical asymptotes, because we're going to learn about this today. This limit as approaches 2 from the left and 2 from the right. That's what that little notation means. Are you guys familiar with it? Have you seen it before? The limit as x approaches 2 from the left of your function f of x and as approaches 2 from the right. So if I've got this graph put in here, just so we can look at it and we have an idea of what's happening with it. I told you my asymptotes, I've got x equals 2. Got something there. I've got this coming across my horizontal. And I am checking this as I come into my graph from the left side of 2. And if I'm thinking about really putting in a number and I'm talking about something that's on the left side of 2, that's actually smaller. That x is smaller than 2. So my value is negative. When I come out with a smaller value than 2, I get a negative value. I divide that into 1, and that's where that negative infinity comes from. So what I'm saying is I'm approaching from that left side of 2, and I'm coming from this left side. My graph is going to dive down to infinity, negative-wise, if I'm on the left side of 2. On the right side of 2, and think about this, I've got x, positive x, bigger than 2. It's on the right side of 2. As I come in on this side, it's actually going to be a positive infinity as my graph kind of takes off and goes to infinity that way. So this is the picture of my graph, and we're talking about what it's going to look like on either side of the vertical asymptote. Okay, a lot of folks go, well, I can look at that on my calculator. Yep, you can, but keep in mind, I'm also expecting you to realize what that graphing is looking like, and it's quicker just to see it as you think about that algebraically. And that's where we're talking about the left side and right side of 2. Questions regarding this at all? Some of it's familiar, seen it before, or is it new, this left and right side of your asymptote? Okay. Now, the line y equals v is a horizontal asymptote. Okay. If it approaches a particular value as you look at it as x approaches negative infinity and positive infinity. The line x equal a is a vertical asymptote of the graph of f. If I have a left, approaching it from the left and approaching it from the right, and I put in there as x approaches a from the left and as x approaches a from the right, and where it's going to go, whether it's going to drive up or dive down, just depends on how it is on either side of that asymptote. And that's what we're going to be comparing. And the graph we're starting out with is exactly the one I did on the front side. Bless you. And what I'd like you to do is keep in mind what was going on with that front side. I kind of exampled it because I want you to try this one on your own. We just did it, or I just did it. You kind of got able to watch because you didn't have a graphing spot. So go ahead and give it a try. This is a transformation of which basic function, okay? And then I just want to make sure that you recognize what you're doing when you graph it, and then be able to compare what's going on with what the characteristics of the graph as it approaches the asymptote from the left and right. Give it a try. Okay, it'll hopefully explain what I did when I did it up front. It's kind of a crowded desk. Okay, so I've got my basic function going on here. It's a reciprocal function, and its general form is 1 over x. Okay, and we're working with the reciprocal function a lot today as we go through. I know this has got a VA. You know, it's going to horizontal shift, right 2 units, just like we said. I've got a VA and an HA. Exactly what I said on the front side. I can put them in. Hopefully you've got it graphed to a certain point. I can even find my y-intercept here. Okay, so if I'm looking for my y-intercept, I put 0 in. I got my y-intercept is going to be 0 for my x and -1/2 for my y. So I can actually graph that, and I know that that's going to be coming through here. Okay, so when I make sure I've got my asymptotes put down and my graph coming in, and well, -1/2. Somebody's got to be able to go -1/2 when he writes it and doesn't put it in. Okay, but keep in mind you should be able to find that y-intercept each time as you go through, if it's there. Questions about it? Now, what's with the limit thing? This, you know, exactly what we did before, but you know, previously on the other screen. But I want to make sure you understand how it gives me an idea what's going to happen to my graph around the asymptote. Okay, I want to make sure it's clear about that. Anybody got a question about how I'm doing it, how I'm evaluating it? Okay, I look for an incredibly small difference. Okay, if I'm approaching from 2, I'm approaching my asymptote to the right. I'm on my left side, I should say. That's what this means. I'm approaching 2 from the negative side. Okay, I'm going to just incredibly small value, like 1.999999. Okay, it's going to be having a difference here of, you know, for 1 minus x minus 2, it's going to be -0.0000000001. Well, that divides into 1, and that's infinite. Okay, it's a really big number. The closer I get, the bigger that number will be. But because it's negative, that's why it's diving down. Okay, that was a pick of mine in my head that as I do it. If I look on the right, something just on the right side of 2, okay, like 2.0000000001. If I subtract 2 from it, I got 0.00000001. And it's positive, and it's going to go on the 1, and it's going to go in there a lot of times. Okay, so it's going to drive up along that asymptote. That's how I know that it finishes up on the upside. Okay, now some of you go, yeah, Bloom, I know this, but we're going to be doing it with other functions too, calculator free. Okay, so the better you are at recognizing what's happening as we approach those around our asymptotes, the easier it is to have an idea of how a function is going to behave and what its graph looks like before we even look at it on the calculator. Now, as far as our evaluation of what's going on with the basic reciprocal function, and this is this one. As we go through, we talk about its domain from -infinity to 0 and 0 to infinity. Talk about its range from negative, and remember, range is y, from -infinity to 0 because of our asymptote, up to, you know, from 0 to infinity. We're talking about continuity. Okay, it's continuous along its entire domain except for its asymptote at x equals 0. It's decreasing. Okay, if I look at the function, it's decreasing all the time from -infinity to 0, and from 0 to positive infinity, it's decreasing all the time. Symmetric with respect to the origin, or we can say it's odd. Okay, in this case, because it's got origin symmetry. As we rotate it 180 degrees, it comes back to itself. It's unbounded. There's no local extrema. Horizontal asymptotes y equals 0. Vertical asymptote x equals 0. And we have end behavior both at that approaching 0. Okay, that's how we were able to find our horizontal asymptote. We'll be listing this stuff in questions on the assignment. And that's how we'll be looking at it. And it's the same stuff we started with when we talked about parent functions in section 1.3. So we're just extending the idea of it. Okay. Now, I want to sketch this graph, and I'm looking at this stuff as we go through. Whoa, we're going to get rid of this stuff. And I want to talk about sketching the graph and find an equation for the function h. Now, I've got h of x. I know we're taking f of x, we're changing it based on the information provided. Okay, we're going to translate it 5 units to the right and then followed by a reflection across the x-axis. Okay, so that reflection across the x-axis is going to take a negative value times the entire function. Okay, not inside in the bottom part of x. We're translating 5 units to the right, so we're going to subtract 5. So it's going to look like that for our function. Now, I want to find VA, I want to find HA, and I want to know what the limits are on either side, okay, of my vertical asymptote. So find that stuff first before you even start graphing. And I know I kind of gave it away because I left those reds in there. I thought I had hidden them. But make sure as you're going through, these are the things I'm finding before I even put my pencil on my graph to start graphing it. So I got my vertical asymptote at x equals 5. My horizontal, okay, it's going to be at y equals 0 because if x is really huge and it's a limit. And my horizontal asymptote has that end behavior limit. Maybe I should use that black. The end behavior limit helps me find my horizontal asymptote. It's my limit as x approaches negative infinity or positive infinity of, in this case, h of x. So as x gets incredibly huge, my answer for h of x, even if it's negative, is going to tend to 0. So that's where I get my idea that it's a horizontal asymptote at 0. Okay. My HA, that's my 0 asymptote. That's what I'm doing there. That's y equals 0. And that's my end behavior asymptote. And it's what horizontal line is it approaching. My limit here of h of x as x approaches 5 from the left and as it approaches 5 from the right is my behavior of my graph around my asymptotes. So I don't have to look at the graph anymore. I can actually create the graph based on these pieces of information that I'm finding. So when I'm looking at this, I've got the limit of h of x, and remember h of x is 1 over, negative 1 over x minus 5. As I approach it from the negative side of 5, like 4.9999999, okay, I'm going to subtract that. So underneath there, I've got a negative. As I'm looking at it, I'm thinking in my head, I've got the negative on top. And if I subtract this 4.9999 repeating, if I subtract it from 5, I got 0.00000000001 that's going in there. But it's negative on the bottom. So I got a negative divided by a negative, which is positive. So my graph is going to tend to infinity around that side. So what I'm saying is, as I go through, it's going to go jutting up this way, like that. Now, I should be able to tell, and I should have found it first, what my y-intercept is. When around 0, it should be like 1/5, because my y-intercept is when x0 is equal to negative 1 over 0 minus 5. And that's why I'm saying it's 1/5. So my graph really should be down a little bit more like that. Okay. Are you okay with the fact that if I take my regular function, my 1 over x, I've just flipped it across the axis. Okay, my other side is going to be down here. If I'm looking at this side, if I'm approaching on this side for my limit, and I'm thinking about, okay, so now I'm at 5.000000001, but that's positive. I subtract 5 from it. I divide that into 1, it goes in there a huge number of times, but it's negative. My graph on this side should look like this, take on this characteristic as I look at it. Okay, because as I'm coming on that side, I got negative infinity. So the green is telling me what my graph is going to behave like around the vertical asymptotes. The black tells me what's going to happen around the horizontal asymptotes. This is my horizontal asymptote. This is about my vertical asymptotes. Okay, as I step through that, and I know what VA is, I know what HA is, okay, and then I got my regular function. Are you okay with the things I found and how I used them? Are there any follow-ups? Okay, so now with that information provided and things going on here, I want you guys to try this next one. See how you do. We got things in there to remind you. Go for it. See what's up. Yep. No problem. No problem. Thank you. Now we have a vertical stretch of 3. We're translating it 4 units to the left, okay, and we're dropping it down 2 units. Vertical stretch of 3, translated 4 to the left, dropping down 2. My HA, my VA, something I can find quickly. Remember, VA is my restriction on the bottom, x plus 4, so x can't be -4. That's my VA, okay? So I got that vertical line at x equal -4. My horizontal, remember, end behavior. So my end behavior, my limit as x approaches -infinity, and my limit as x approaches +infinity of kx. Excuse me, let me be able to write that a little bit better and see if it was the board or me. Okay, it was me. I've got to be thinking about what those things are, what those limits are going to be as I step through this. So I'm looking at, as I go to -infinity, this value goes to 0. Here, that 3 over x plus 4 goes to 0. But then I have subtract 2 from that. So I should be getting my HA there at -2. And even if I approach +infinity, this is so big on the bottom, going into 3, it's going to go in there 0 times. Well, it's going to approach 0, and then again, I'm going to subtract 2 from it, and then again, that's -2. So my HA should be y equal -2, and that's how that is driven, okay? So I've got my vertical and horizontal asymptotes. Now, keep in mind, I got a vertical asymptote, and I have to test it on the left and right of my vertical asymptote, my left side of that value 4, my right side of the value 4, and when I test them, I'm looking at -infinity and +infinity respectively, okay? So I know what my graph is doing. I know it's going to stretch. I don't reflect the graph, so it's in the general position of the parent function when I'm looking at this. But if I go to -4, 1, 2, 3, 4, I got my asymptotes going on, down 2, okay, that moved where my horizontal and vertical asymptotes cross. Well, that makes sense. I've got my HA of -2, and I'm coming through here and there, but I'm going to make sure about my y-intercept because I have k of 0 equal 3 over 0 plus 4 minus 2. Well, that's going to be -1.25. Okay, and it makes sense that at 0, -1.25, I have a y-intercept. Okay, as I prep my function. And look at the pieces that I have. Look at the stuff that I've laid out and the stuff I can find calculator free. okay, as I set up my function. Questions? Okay, now the blue is kind of our hint. How can we analyze a transformation if the equation isn't in transformation form already? Okay, because a lot of it was pre-done. We had a really easy time about doing stuff. I found stuff that I want you to be getting in the habit of finding. I'm going to expect to see it if I have a problem like this on the exam for analyzing what's going on. Define the VA, define the HA, define the limit on the left and right of your vertical asymptote, define the limit, you know, to show you that's how you're finding your HA, which is really your end behavior limit. Okay, so when I'm stepping through and getting those things done, we want to make sure we recognize those are the steps that we're looking for. Transformation of a reciprocal function. If you have a graph of any non-zero rational function of the form g of x, where ax plus b is divided by cx plus d, that can be obtained through transformations of the graph of a reciprocal function. If the degree of the numerator is greater than or equal to the degree of the denominator, we can use the polynomial division and just use long division and polynomial division to rewrite the rational function. So we're going to rewrite it, just dividing things out. Okay, so we get it in transformational form. Now, part of this is this one's already here. I've got it in transformational form, and I've got myself some hints about what I wanted to find when I was going through this. But keep in mind, I'm going to take it out. I've got 2, so I've got a vertical stretch of 2. I've got a shift to the left of -3 as I go, so I can talk about those things, you know, compared to my f of x, you know, when they're talking about this. I do not have to have you talk about it as the parent function, but they asked me to, so I thought I'd put it in there. So I have vertical stretch by a factor of 2. I've got that left, excuse me, 3 units as I'm going through. I'm able to find my VA. I'm able to find my HA based on the information provided. My VA x is -3. My HA is 0. Y equals 0 as I'm approaching from negative infinity to infinity. It'll approach 0. My end behavior limit helps me find my horizontal asymptote. Okay, what it tends to, what it converges on. I don't know why I have things in there. Okay, so I'm looking at this as I'm going through, and I've got that going on. And let's pop that over so we can just focus on just that one thing that I'm talking about. So as I'm stepping through here, we got this stuff. Apparently it was some other work, but I want to be able to find my y-intercept and graph the function. So figure out what's going on around the left and right of -3, the left of -3, the right of -3, you know, the left and right of our asymptotes we have nailed down here. Find your y-intercept, then go ahead and graph your function. And after you're comfortable graphing that, look at the next one and think about what we got to do. Remember, my y-intercept, I put 0 in, and I get 0 equals, and I put in 0 for x and I get y equal 2/3. There's no x-intercept. It won't cross the x-axis. Okay. My graph is going to come down along here, and I've got that nailed down because I was able to look at my limits on the left and right of 3. On the left side, it went down to -infinity. On the right side, it went to positive. It's coming out of positive infinity and coming across. So I was able to determine that whether it dove up or dove down based on those. Okay, does that help on why I'm checking those? Are there any clarification points? Now, when I have a rational function, polynomial over polynomial, the idea of it is I can be able to use division to break it down so I can put it in transformational form. So with this next part, as we look through these, I'm allowed to actually touch the board here. It's kind of flipping out. I want to make a division. I've got x minus 2 going into 3x minus 7. I know x minus 2 will go in there 3 times. Okay, so I do my multiplication. Remember, I multiply this when I've got long division. Y'all, if you did it here at Elk River High School, you did it in Expo. Okay, probably first semester, and the goal is to match that front. Okay, I don't care what else is going on. I got to pay attention to, x squared, x, and whatever's in there. But once I do, I want to match the front. So I got 3x here, minus 6. But I'm going to subtract this. Okay, so now I've got negative 1 as my remainder. You okay with what I'm doing with that, long division wise? Now a rewrite of that function becomes negative 1 x minus 2, because 3, and I'm still dividing, that's really my remainder. But we like to look at it this way when we're looking at transformational form. Let's get rid of that. Okay, we like to look at it that way when I'm talking about transformational form. Okay, so now I can read stuff from my function. Questions about what I'm doing so far? You okay with long division? You okay with the result of that long division? Okay, is going to be giving me information about my function, specifically the transformational form, where I know I'm going to move it right 2 units, I'm going to move it up 3 units on my graph. Okay, and incidentally, it's going to tell me my end behavior horizontal asymptote too. Okay, because as I approach negative infinity, infinity, this front term becomes 0, and I add 3 to it. So that's my horizontal asymptote. Okay, if I talk about this, I'm talking about our reflection, I'm talking about my horizontal shift. But I'm looking at my end behavior. I've got, it's going to have an HA of 3. My VA is 2. My y-intercept, I put 0 in there. I got negative 1/2 plus 3. And I should be able, 7/2, or be able to talk about 3.5 as I talk about it, because it's negative 1 over negative 2, and it's a half plus 3. That's where 3/2 comes from. My x-intercept, okay, if I wanted to go through that, is 7/3, 0. Now I find out where 0 is, and I solve for that on the side, because it's going to cross my x-axis. So if I pop those on, if I can get rid of my little screen. Okay, so I've got this going on. And I'm able to look at my left and right as I'm talking about my limits, what happens at the asymptotes. So as I come from the left side, it's going to go to positive infinity. I'm coming from the right side, it drives down to negative infinity. So I've got my graph looking like this. And I got 0 and 7/2, so it's 3.5, right about there. My graph's going to do this. Slide it over a little bit. Okay, let's pretend it doesn't have the bumpy road. The other side of my graph does this portion and comes through here, roughly, as I graph my function. Are you okay with this picture? And all the information I can find, all the things I can label that help me find my graph without a calculator. Now, as we talk about the graphs themselves, and I guess I've got probably some folks wondering about how I found my x-intercept. I want to make sure that it's clear what I did. I just solved this for x. Okay, that's how I found it. So at that -3, I'm going to multiply across by x minus 2 equals -1. I distribute -3x. I don't even have to distribute. I got x minus 2 equals 1/3. I can get my 1/3 in there. I think I add 6/3, and that's where I get 7/3. So I'm able to find my x-intercept and y-intercept straightforwardly. I expect you guys to be able to do that. Those should be great points on your graph. Okay, when you're asked to graph a function, I'm looking for the intercept spots. I'm looking for the area around your asymptotes, whether it's going to go to the infinity or positive infinity or negative infinity. I'm looking at the end behavior around your horizontal asymptotes. All right, so there's like x-intercept, y-intercept, my vertical asymptotes, horizontal asymptotes, the look of the graph, the vertical and horizontal lines. There's like 6 to 8 things on the graph itself now that I'm looking for to give you points. Okay, so it's going to be like 2 or 3 points for just the graph itself. Okay, so pay attention to those things. And most of the stuff I'm listing off isn't given to you by a calculator. Okay. Now, as we're looking at problems like this next one, I want to be clear about why I'm doing what I'm doing and how it's happening. I know stuff about the graph. I know I got a vertical asymptote at 2. I know I got a horizontal asymptote at 0 right off the bat. Okay, I can look at that. I can do the end behavior calculation stuff and know my restrictions. I can go 4 minus 2x equals 0. Totally get where that's going to go. Okay, but I want to be able to put it in transformational form. Okay, and in doing so, I manipulate my denominator. In my transformational form, I never have a number right there next to the x. I always have a 1 there. Okay, so I want to divide out that 2. So keep in mind, I'm just going to divide that out. So I've got 6 on top. I got -2 x minus 2. Okay. Now keep in mind, 6 divided by -2, that's -3. So I've got a value. I've got -3 on top, x minus 2 on the bottom, which is a different way of looking at it. I've got a reflection over the x-axis, a vertical stretch of 3. I'm moving the graph 2 units to the right. Okay, I already knew I was moving it 2 units to the right based on my restrictions of my denominator. Okay, looking at it, but now I can almost guarantee, hey, it's there. We can actually see it, parent function form, and we can see how it's being translated over. Okay, now keep in mind with those things, I've got those in, and I can talk about my end behavior as I'm talking about my limits, my VA, my HA, but let's talk about our order. Okay, so reflect over the x-axis. Vertical shift by a factor of 3. Vertical stretch by a factor of 3. Horizontal shift by 2 units as I'm stepping through that. My VA, HA, I'm going to list them. I got them in my graph, but I'm going to be asked to list them in a chart even. We'll give you a chart. Hence, hence, hence. Okay, my y-intercept, well, that's when x is 0, it's going to be 3 halves, 0, 3 halves. There isn't an x-intercept, it's not going to cross the x-axis in this case. Now, my behavior of my graph as I approach from the left side of -2, something incredibly small is it's positive. It's going to go up because it's going to be on the left side of 2. So it's going to be negative here because it's like 1.999999, so it's negative on the bottom, negative on top, so it should be infinity, positive infinity should go to. So I got my top going up, I'm predicting my bottom's going to go down, and it does. So this is where my graph's going to go as I put in my little points and I check it out, and I'm happy with it. But the examples that we showed on this page, keep in mind that U-try example is a division, a reorder of your denominator. You want to make sure it's in that transformational form. And I do a division on the other one, which is a long division, to show the remainder. And that remainder that I've got going on there is the function that I'm actually graphing with my K being my up and down. We're going to find out that that value that we have on top of our divisor, not our divisor, but our quotient as we go through, we're coming up with our actual asymptote, and we're eventually going to see slant asymptotes coming out of that as we go through this next couple steps. That slant asymptote is kind of a neat response to that division. Now, our last one is kind of an interesting one, talking about our divisions. We got a graph of this. I put it in my calculator, and that's what my graph comes out to be. Okay. I got your horizontal asymptote, but I'm going to talk about what those things happen on. I've got my denominator here is smaller, same power, but smaller than my numerator, so I'm just going to divide them in. So I've got that in there, so I should have 1 coming across with my 1 remainder. I rewrite my function. I put it in a form that I'm used to seeing. It's not going to cross the axis at all. I kind of look at it because it's always positive. Okay, there's no restrictions on that. There's no vertical asymptote at all, but it is approaching 1, my horizontal asymptote. So I got no vertical asymptotes, and it's approaching 1 is for my horizontal asymptote. Those are the things I know. And that bump, I just put 0 in. So I got 0, I got 1 plus 1, and that's where I get my 2 on that. And then my last things here, if I talk about the limits, that's how also I know that my HA is approaching, it's approaching 1 because I'm from negative infinity and positive infinity, my end behavior limits. But I was able to figure that, surmise that from my graph as well. Not my graph, but my equation before I even got there. And I have an X or Y intercept here. If I talk about my Y intercept, okay, it's when I plug in from my Y, 0 plus 1 plus 1, that's where I get 2, so I've got 0, 2. That totally makes sense that I'm coming up here at 0, 2, and that's where my high part of my graph comes. This might be a really funky looking function as you go, as far as seeing something like this for the first time, but we have some ideas about what is our horizontal asymptote, that we didn't have a vertical asymptote, what our X value is, that Y doesn't cross the, doesn't cross the X-axis, but our Y-intercept, I should say. Putting in X is 0. Now, summarize what we've done today. And again, we're looking at end behavior. Okay, so if we look at our graph, and this N and M is referring to the powers in our term number. M is the power and term number of the denominator. N's the power and term number of the numerator. The end behavior asymptote is the horizontal asymptote, y equals 0, if my power in the denominator is greater than the power in the numerator. Okay. If they're equal, my N and M are equal, my powers. And I'm talking about the largest one. I don't care about the other 3 or 4 terms in there. I'm talking about the largest power, okay? And the numerator and denominator, comparing them. If they're the same, then the coefficients, that the leading coefficients of those values determine what's going on about my end behavior asymptote, my horizontal asymptote. Okay. If n, which is the top power, is larger than m, the bottom power, then it's going to not have a horizontal asymptote. Okay. But all this end behavior asymptote stuff is all about that limit as x approaches infinity and negative infinity. Okay. I don't memorize that stuff because I look at that as the determination of what's going to happen in my function, what it's converging to. We have vertical asymptotes. We'll talk about this tomorrow. This slant asymptote, there is no horizontal asymptote. If we know there is no horizontal asymptote, then we look for a slant asymptote, and we're going to make a division. We're going to talk about that tomorrow. Vertical asymptotes, these occur at the real zeros of the denominator, okay, provided that the zeros are not also zeros of the numerator of equal or greater multiplicity. Remember, if there's zeros in the numerator, it's a removable discontinuity, and that's a whole. X-intercepts, these occur at the real zeros of the numerator, which are not also zero of the denominator. So, you know, where y is 0, my y-intercepts where x is 0, and I plug it in. Okay, so I should be able to find those things on my graph and be able to list what they are. Okay, the hardest thing is just remembering everything. That's why we give you an actual list when you're going through it, and I'll be giving you guys like a piece of paper to help you with your assignment in some cases that have the graph in the list of things you need to check. That's it for today's stuff. That's tomorrow. The assignment that we have for today, I can get to that back side. That's our day 1, 2, and 3 assignments. And we've got that going for y'all. Are they different? They shouldn't be. 1 through 9 odd, 11 through 18. Tell you what, just go 22, 21. Don't do these today because I think I put those on tomorrow's. And I think I just doubled that up. So I just went a little crazy. I apologize. Okay. But to help you out on the assignment, and you may be using this tomorrow or the next day, but I just want to put this out for you so you got a grid. You got stuff to write down, the things I'm going to be looking for. Remember odd and even functions.